Let's go ahead and do our setup here for these stone structures. Alright, we're going to use curves to do this because that makes it pretty flexible for us. So hop into a front view, hit enter. Might need to adjust this here. I turned down my grid snapping here just so I have more control over my drawing. Let's start with sort of a castle wall shape, or you know, that sort of tower turret kind of thing you see there. Let's do something simple. We'll modify this a little later as well, just to show you that there's possibilities here. And we're just going to create a closed shape. Right, so we got a really simple shape there, and let's get out of that. So that's our basic wall shape, right? So first thing we want to do is extrude this so we have some mass to it, and we're going to go ahead and say bring that forward a bit, put it back on it, okay, and we're going to bend this, but just to make sure that we don't get any weird kind of issues with limits and all that, because you can see that some of these are not even segments and some of these points are actually duplicated if you were to look carefully in the curve. Let's take a look. Yeah, you can see there's actually duplicate points here. So there's a number of ways you can address this, but one of the easiest things for the use case that we're doing, we're going to turn all this into little stones. So let's just get a more uniform mesh, and we'll use the lab's fast remesh for that because it's nice and easy and convenient. And instead of target length, we're going to use poly count, and I do not need 50,000. Let's just try, say, 5,000, and do some more relaxed iterations so that we get something that's a little bit more uniform. We don't really care about the normals at this point because we're going to chop all this up anyway. But there we have a sort of a consistent shape of what we're doing here. And then what we're going to do here is I'm going to go ahead and add a bend just to give it a little more interest. So in my bend node, the first thing I'm going to do is set up a capture region to start from the center and go to the max X to the right there, and that's that. Go back to my view here, and you can see just by default it's going to be kind of messed up, so we need to we need to rotate this axis 90 degrees here, this up vector. So there we go. So now it's in the proper orientation, and then we're going to deform in both directions, and let's just say we'll do that, and now we have that sort of classic shape there. And of course you can make this more complicated and you do a 180 degrees so that it's a complete circle or something like that, but this is just a simple example, a simple shape. Okay, so now let's turn this into little stones. So now that we have a uniform shape, we're gonna scatter some points on this, and let's just start with a low reasonable number here, and we're gonna just simply use the simple Voronoi, however you want to pronounce it, and we're going to use our scatter points as the guide, and we are going to take this and make sure that we output the primitive piece. So every time it makes a cut, it's going to have a piece attribute, and we want that for our loop that we're going to do in a second here. So let's go ahead and clean this up. So you can see this is what we have, just a very simple setup, and this curve can be any shape that you want. And from here we're going to start with our for each loop, but in this case we're going to do a named primitive, right? Because we want to work on each piece. And right off the bat, we're going to use this create meta import node, because I am going to use the iteration in a second. So first thing we need to do, let's turn these into a VDB shapes from polygons, right? So we're going to go drop this down here, and we should have a pretty low number. Make sure everything's set correctly. Now the voxel size is kind of big for something this small. As you can see, it's only 1 meter. So let's lower this a bit. We can experiment and just see where we end up. Okay, it's gonna do its little calculation there, and you can see that we've got let me change this to smooth shaded. We've got some simple, real nice shapes, and these are individual pieces, right? So let's clean that up a little bit with say a VDB smooth. We have a couple options. Either one of these is going to work in this case. I'll just go with the second one there. Give it a second to calculate, and there we go. I mean, that's a little cartoonish, so let's relax the iterations a little bit on that. Let it do its thing. Okay, so that looks a little better. And as far as the smoothness, I mean, we'll add a material in a later section, and we'll use some displacement to give it a little more interest on this. But there's our sort of rudimentary beginning of our shape there. Let's do a couple more things with this to make it a little bit more interesting. So for each piece here, this is a VDB at the moment, so we can't actually texture it, right, as far as you know, UVs are concerned, or you know, a texture map or anything like that. So we need to convert this back to a polygon, right? So we want to convert VDB, and give that a second. We are going to need to change it to polygons, right? And this is why I wanted to use a low number, so it's quick. Let's bring back our wire shading here. You can see, so now we have actual polygons, and each one of these is a unique piece. So that means we can actually create a UV for each piece, right? So let's do that. That way, when we do our texturing later on, we will have each piece individually textured by our texture maps, right? Okay. Now this is good to do it this way. It's kind of important, especially if you're going to do anything like anything dynamic with this. So like RBD simulation, which I'll probably add a quick little bonus chapter on this to just do a really quick, simple setup on it, so you can see that these are sticky UVs, right? It's on each piece, right? So okay, let's add a little more interest to this, and let's do a quick little transform for each one of these pieces, just to make it a little more interesting. So first thing I need to do is I need to make sure that for each piece in this loop that the pivot is at the center of each stone, right? So that's really simple. All you have to do is use a simple expression here for each one of these axes, and that's centering the axis point. Let me I'm gonna turn this what do you call it, if I can move this window here. Sorry, I have this little recorder that I can't seem to move. Okay, I'm just gonna be stuck with it, I guess, because I can't access it. My mouse can't get there. So so for each axis, I'm just gonna put this this $, center expression, right? So now what happens is that for each piece in the loop, it'll have its pivot in the center of each one of these stones, right? And now I want to rotate them, each one a little bit randomly, and this is where I want to use the iteration from the metadata, right? So I'm going to go into this, and I'm going to actually copy an expression because I already built all this before recording this. And in the rotates for the X and the Y, or all three if you want to, you can just write this simple little expression. Let me bring this out a little bit. Yeah, sorry about that cooking there. I probably should have thought of that ahead of time and made it so I can click the little button at the bottom. So anyway, what I'm going to do here is I'm going to do a fit 01, because if I decide to change the number of pieces, the number of stones, like in this case we have 250, so we have a number of 250 pieces, and I want to randomly rotate each piece. Well, I need to get those 250 pieces, you know, fitting through 0 and 1, so that I can multiply it, you know, by, you know, a certain degree of turn for each iteration. So that's why I'm using a fit 01 here. Otherwise, this multiplier, you know, would be whatever number of points I have, and it'll just be all chaos. So I do a fit 01 and then do a random selection from my iteration, which is from the detail attribute, which is what this expression is doing, and then I'm remapping that to a range. So in this case, just a little bit on what is this, the x-axis, so it's like -8 degrees to 8 degrees, and I could you know, do a similar thing, say on the y-axis, and change it to something, say, you know, a little less, just really subtle, and then let it do its cook again. And you can, if you look, you can probably see that each one of these pieces does have a slight rotation, like a randomized rotation to it, rather than just being just a simple, like everything is just kind of glued together, weird, in a sort of clean, you know, way. Makes it a little bit more organic, and you play with those values as you see fit. And I think that's it for the basic setup of this, right? So this is getting your basic, you know, using a basic shape to do a simple stone structure. And you know, like I said before, yes, this is, I mean, these are smooth rocks, but we're going to use like material displacement to add a little more interest. But real quick, just to show you how easy this is to sort of modify, let's just go back to this curve here and say we wanted to make this a little more interesting. I'm going to go ahead and, you know, say make this top part round. Go into my edit mode and select this one and say move it up one, and, you know, make a sort of rounded top there, and go back to my view, and I don't really have to touch anything else. I could just go back to the end of my loop and just let it cook again. It'll take that shape and make it the way I want it, and now I have this, you know, something that's a little more interesting, right, to look at, and it's pretty quick. And again, each one of these pieces has their own UVs, which will help later on. So I think what I'm going to do next is I'm going to do a quick little chapter on just doing a simple RBD setup, where we can dynamically activate these stones to sort of follow the ground. So, you know, something that like you might see in Game of Thrones, whatever, where you have like the dragon fire coming in and sort of like the walls are sort of like exploding or just falling apart and falling down, however you want to do it. We won't do any real elaborate like explosions or anything, but I'll do a quick little setup in the next chapter here. Alright, so I'll see you in a second. Okay guys, in this section we're going to build a simple little dynamic RBD setup. But real quick, I was looking at this before I wanted to get into the next step and thinking we could probably stand to make this a little bit more interesting. So something we can do here is go back into our scatter node and try to make this a little less uniform. You know, so we can mess around with things like the relax iterations. So this is kind of heavy-handed, and also the spacing. There's, you know, pretty big gaps there. We can address that by scaling our radii down a little bit. So let's try a couple things here. Let's bring this iterations down quite a bit to say something like 2, and then just take a look at that while it's at a low number there. And you can see we're getting more variation in the stone shape, which is a plus already. So let's say bring this radius down by 1/4 and see how that helps us as well. And already we have much more interesting stuff to look at. So yeah, I mean, that's a win in my book. And then we could add a little bit more of a count. I'm going to bring that back down in a second when we build our RBD, just to sort of save time a little bit, but I just want to see what this looks like. when it's done. So yeah, that looks a little better. I mean, you'll have to address the radius, you know, as you go, you know, depending on, you know, how you, you know, whatever seed you use or whatever. But like I said, seasoned to taste is what I usually say in matters like this. So we bring that number back down, and let's just use this as our starting point for the RBD. And also, the smoothing is bothering me a little bit, so I kind of want to bring that down a bit. Sorry, I know I said I was going to move along here, but let's just make this look a little better. Yeah. Okay. That's a better starting point than where we left off. Okay, so let's get going here. One thing we do know is that our structure itself is a little bit on the small side for a sim. So it's gonna look probably like, you know, like a toy wall falling down. So we could probably stand to make it much bigger. So let's drop in a transform here, and you know, just say scale this up by 10, and see what that, you know, gives us about a 10 meter by 10 meters. So it's about 20 meters wide and so forth. So that'll look a little bit more interesting when we do an RBD sim on it. So first thing we need to do is we need to take all of these prims and points, which is kind of a lot for an RBD sim, and just sort of compact them down into individual stone pieces for the RBD that you know, is going to work a little bit better, more friendly for the solver. So let's use an assemble node and create packed primitives based on the pieces that it sees. As soon as we do that, we're going to lose our UV, so we need to make sure that we transfer attributes here to grab the UV. And now we can do some configuration, right? So let's do an RBD configure, and let's just take a look at what we have here. Grab that name for the attribute, and for the most part this is all good here. We do want, I'm going to use a constraint to sort of keep everything together, and then use a bounding box to sort of reveal the pieces so that they fall apart gradually. So I'm going to turn this constraint on. I'm going to say use bounds, and that way I can use this last input, static bounds geometry. So let's do that real quick before we get too far into this. Okay, there we go. Let's just use a quick little cube here. Template this assemble node. Change our view to the box. Let's get into one of the orthographic views. Alright, so I'm going to, on the first frame, I'm just going to make sure that the box is, you know, sort of sized the way it needs to be to cover the whole thing. Alright, so that shows everything, and it's important to move yourself to a front view so you can see that we did need to add height to that. So now we know that it's completely covered, right? And we're going to animate this shape over time. So we're going to start out with it fully covered so that none of the pieces are moving, right? And as we move the box away or reduce it, it'll activate the pieces, right? So let's do that. Let's move down to say, well, first of all, let's add keyframes. There we go. And then say go to frame 48, and we are in the front, right? So let's say from right to left we reveal the wall, and then there we go. Right, so it should animate like that, and then as it animates, the stone pieces will be activated and fall to the ground. Easy peasy. And then we'll feed that into our static bounds geometry. Take this off and look at this. Go back to our view here, and let's just double check anything else we need to look at here. Alright, now let's feed this into a solver. RBD bullet solver, there we go. And we do need a ground plane, so let's go into our setup, collision, scroll down to ground collision and change this to a ground plane. You could also use a height field, so if you want to do a custom like terrain kind of thing, you know, where say this is like sitting on a little hill or something like that, and you know, you want to sort of fall down a, you know, the hill, you can do that. What else? Setup. I think we're going to leave this the way it is. Forces would be important for drag and drag spin. So if you have a lot of pieces, the smaller ones in an RBD tend to kind of spin out of control at times. So you generally want to have these checked on. So I usually just go in and check them on. But again, it's one of those season to taste kind of things. And at this point, I think I'm going to pause the video and just do a quick little flip book and to see what we ended up here with. Okay, I'll be right back. Alright, so here we go. This is what it ends up looking like. Just a very simple setup, and as it activates, the pieces start to fall, and there you go. Real simple setup. And again, this whole thing is sort of dynamic, so you can go back and change that curve shape, and everything's going to update and pretty quickly, and you can do a whole bunch of different iterations of different things like this. You know, you could do arches and what have you, and all that kind of stuff, right? So I think that's pretty much it for the simple RBD setup. So let's just make sure that our stuff is cleaned up. Let's do a null here. And I think probably what we should do next is feed this into Solaris and get into Karma and actually just use a very simple material to make this interesting, and maybe add some lighting and motion blur and all that kind of stuff, and just see where we get, so you guys know how to do that too. Okay, so that'll be the next section, I guess. Alright, see you in a few seconds. Alright. Okay guys, let's go ahead and bring this into Solaris and set up a simple Karma render for this. So we can switch over to Solaris, switch into our stage if it doesn't do it automatically for you. And I'm not going to worry about the graph right now. I'm going to do an import, get all my stuff in there. And the first thing I'm going to do is sort of set up the view that I want. This is something like this. Drop down a camera. And then a light would be helpful. Let's do an environment light. And I should have something basic here I could use. Yeah, like a little basic HDRI. Okay, so first things first, with the import, because we packed our geometry when it's a RBD to do the RBD sim and all that, and then we sent that into Solaris, we need to unpack that to get the UVs and everything that were saved with it. So we'll go into our imports here and go into our primitive definition and go down to pack primitives and change this to unpack. And this will make sure that we actually get UVs on there. There's not a straightforward way to see that in the Solaris viewport at the moment. Like there's no button here to show that. But one sort of hack around that you could do if you want to validate that they exist is you could do a SOP modify and set your view to that and change your primitives to what your tree is here for all the little pieces there, and we're going to use unpack USD primitives to polygons just to be able to view them. And if you dive inside, you can see that the UVs actually exist. So this is just a way to validate that they're reading into Solaris, right? So we don't actually need this node for anything, but just showing you a quick little hack around there. Okay, so what are we going to do now? We're going to create a material, I guess, up here. So we'll do a library, drop that in there, dive inside, and let's just keep it simple and do a principled shader, some basic rock. First thing we're going to do is change our base color from this dark gray to white so that it doesn't tint our materials, because we're going to do a PBR shading. use a texture. I already did this before, so I have some textures already available. So I'm just going to go down to like a simple rock, and let's go like that. A diffuse color. I have roughness available to me, which is there. I have some normals, which is right there, and I do have a displacement. So let's use texture displacement. Displace, and you might need to adjust the scale depending on your model and all of that stuff. So for now, let's just see what we end up with here. So we have just a basic texture. I'm going to clear out this library and autofill it, so I have the rock material there, and then I'm going to do an assign material, drop that in between here right after the material library, and control click on this arrow to get my hierarchy there, and control click on the material, get my rock, and that should work like magic. There we go. Okay, cool. So right here, before doing anything else, I'm just going to save. And at the end of the chain here, I'm going to put karma node down there. And let's just make sure that we're bringing in our RBD stuff. Yeah, so it's coming in. I didn't cache this to disk, so it's just kind of like doing whatever I had in the play line. Let's take a look at our camera. Yeah, okay, so we probably want to do some motion blur on this. So on our karma render node, let's just clean that up a little bit. Go into our camera effects, and we're going to make sure that motion blur is checked. We know that we have the V attribute coming in from our RBD Setup by default, so we're going to utilize that. We do have instances, so we'll do that there. It's a good place to save. And this isn't going to work right away. You need to drop down a motion blur node before the karma, and it's going to fail because it hasn't. You haven't identified a camera yet, so you have to control click here and pick your camera that's actually in the scene, and then it will be able to calculate correctly. And again, this is a good place to save, and we should be able to kick off our karma and see some magic. So you can see there's a little bit of motion blur there. I mean, this is sort of a larger scale thing, so they're not moving really fast, but they're moving enough to create some motion blur, as you can see here. And there you go. That is pretty much the setup. And obviously you would do something more beautiful looking than what I just did here. I just showed you the basic fundamentals of it. Let's see, is it done? Yeah, okay. So there it is. That's the basic setup. Bringing it in and setting up motion blur and doing a simple principled shader. And like I said before, your displacement. If we want to, let's go ahead and let's just jump into that just to prove that it works. So let's just say I zoomed in a little bit more here on one of these rocks. On displacement, and let's just say I just wanted to make it more pronounced in the render. You could see that there's more texture displacement on the rock itself, even though there is a little motion blur hiding that. So if I just brought this back, like say to 0.25, like yeah, so clearly there's displacement. That's what I was saying earlier in the first chapter. We didn't have to do any sort of geometry noise or anything like that. It's pretty unnecessary. Just keep the geometry count low and then use materials to do the heavy lifting in cases like this. And there you go. I think that pretty much covers everything, guys. So I'm going to wrap this up, try to keep it under half an hour for you. So not bad. From scratch, about 30 minutes of work, and pretty dynamic, and you can use whatever kind of shapes you want, and it's good for sort of like adding different elements in your scene, or what have you. You know, wide shots, medium shots, whatever. I hope that was helpful. All right, I'll see you guys next time, and thanks for watching again. All right, bye.